Hello, my friends. Welcome back. I'm Dr. Ken Berry. Today, I have an excellent guest for you, Isabella Cooper. She's a PhD research scientist, and we're going to be talking about a smorgasbord of topics today. Each one of these topics probably concerns a question that you have about your diet, about your health, about rumors that you've heard out there on social media about this is bad or that is bad. So I encourage you to sit back and listen to this interview. We're not going to get too deep into the scientific weeds, so I promise you'll be able to understand everything we're talking about, and you'll be able to immediately apply it to your diet and to your lifestyle to improve your health. Without further ado, Isabella Cooper, welcome.
Hello.
I'm so glad to have you on. We've been trying to set this up for a while, and I'm in love with your very large brain, and I want to really pick it today. So I hope you're ready to give the information because I'm ready to dig it out.
Fantastic. Very ready.
Excellent. So the way I understand it, the majority of your research is human physiology, ketosis, insulin. These are kind of the things. Give us kind of a quick synopsis of your research, past, present, and future.
So yeah, the majority of my research is purely in humans. We do ex vivo and in vitro work as well. But as you know, any sort of out of the body cellular work and animal work is often far removed from the real system, right? My work has earlier on, now not so much, but it was originally in females only, and it was partly due to chance, and then the other partly was because, in actual fact, it was quite frustrating to see that there wasn't really any good research in women. Most ketosis research, carbohydrate restriction type research, are done either in a disease cohort, epilepsy, type 2 diabetes, things like this, or they're done in quite high performance athletes, and so not in your regular every day-to-day kind of person who can be fit but just not athletically level trained. Right. And also in females, again, it's usually either they're in post-menopausal women, so that you don't have to deal with a hormonal cycle, or in females who are on some sort of hormonal birth control that will regulate their cycle, which is, again, not really studying natural physiology. And so in that, I sort of thought, well, how can we make so many claims that we make if we don't really know what it looks like in natural physiology, with all the so-called messiness of what life entails, right? This idea that you have to control, where, as an example, in many ketosis versus regular diet studies, they'll also make them isocaloric, thinking that, well, we're going to control for calories and we're just going to show the difference between ketosis and not ketosis. The problem with that is different kind of foods, the macronutrient ratios are going to have hormonal effects that regulate hunger and satiety. So if you make it isocaloric, you've actually done another intervention aside from changes in macronutrients. So, as much as it's nice to say, yeah, but if we control for the calories, we can tell it's just whether it's the ketones or not. But in the real world, people are adopting a ketogenic lifestyle or diet. They're going to experience those kind of potential favors, which is, satiety. And so then we would want to see what that looks like as it naturally evolves.
Absolutely. And this is a problem with all human physiology research. And some people accuse the researchers of being lazy. But I think that what you just said is probably more accurate. You want to control for as many things as you possibly can. And it's my understanding, and I think I heard you talk about this, that the majority of research on ketosis is done in men, or it's done in very, very fit athletes. And so many people make claims out there on social media about ketosis and getting pregnant, ketosis and menopause, ketosis in women in whatever aspect. And, all men know that women are complicated. That's a given. And so, but I can't really blame the researchers for trying to control it for as many things as they can. But at the same time, there are millions of women who are in their reproductive years, or they're perimenopausal, or they're menopausal, or they're postmenopausal. And I feel like you're right. We need research in all those areas.
Yeah. And the thing is, if we want to, let's assume when we say that, well, young, relatively young, sort of healthy cycle, never having had any disease, in, having their menstrual cycle type women become the sort of like, we want to look at that format and consider that the healthy setting. Well, we need that data. So we need to study women in ketosis, in that lifestyle, in a sustained amount of ketosis with having no prior disease and no prior metabolic disease at the very least, and then understanding, well, that's what that signature, that metabolic profile signature looks like. And then any other studies from there would use that as a baseline characteristic, essentially.
Yes. Now, speaking of women, one thing that women are very concerned about, worried about, trying to prevent is osteoporosis. And I know that you have some opinions about that. 99.99% of doctors, if a patient expresses concern about osteoporosis, they're going to check a bone mineral density, right? And that's literally the end all be all. You're going to check that one test, and then based on that, also 99% of the time, they're not going to give any dietary recommendations whatsoever. They're going to say, oh, you need Fosamax or Actonil or one of the other osteoporosis medications to either prevent or to treat. There's another factor to this osteoporosis question, which gets very frequently ignored, almost uniformly ignored. Tell us what's the other thing that women should be worried about if they're worried their mom had osteoporosis and they do not want osteoporosis because the kyphosis, the fractures, nobody wants that. What's the other thing women should be looking at besides their bone mineral density?
Well, the problem with the bone mineral density problem with it is, of course, if it's lower, a lot lower, then of course that's a risk of osteoporosis, fragility, fracture risk. But the thing is that normal weight hyperinsulinemic people and even obese will actually have normal bone mineral density and higher the more hyperinsulinemic they are. So they're going to be led into a false sense of security, in actual fact, thinking that they don't have a risk of fracture, because in actual fact, in the hyperinsulinemic setting, the higher your bone mineral density is, the greater your fragility fracture risk is. And it really shouldn't be called, obviously it's not osteoporosis, porosis indicating, porous bones, so low bone mineral density. It's not the same disease. And it's a big problem in the published literature because the fragility fractures that you see in postmenopausal women and obesity, type 2 diabetes, which we know are increased risk factors for fragility fractures, they're pulling the nomenclature. So they're calling it osteoporosis, but they're not. And, properly measured, they're really not. What is happening is they are hypermineralizing their bones instead.
And I tell people this all the time, speaking from a clinical perspective, the bone mineral density does not measure bone strength. But that's what the average patient, that's what they want, is they want to have strong bones that don't break when they fall. Right now, if you fall off the house, you're going to break a bone. But I'm talking about women who step off the curb and break an ankle, or they fall from a standing height and break their wrist. That shouldn't happen in a woman with healthy, strong bones. And so the bone mineral density test was actually basically designed by the pharmaceutical companies to show that their pharmaceuticals increase your bone density, because the only way to measure bone strength is to push somebody down the steps. That's really the only way to do it. You can measure bone density with a machine. And so what I hear you saying is just because your bones are very dense, that does not mean that they are very strong.
Exactly. You can have, we build really tall buildings, but they've got steel inside of that concrete to give it this sort of torsion strength. Otherwise, something that could be very dense, but also very brittle at the same time.
Absolutely. And so for a woman, if they want to really find out if they have strong bones, a bone mineral density test does play a role, but they also need to check their fasting insulin, don't they? And if they turn out to be hyperinsulinemic, and they can't just blindly trust the BMD measurement. They need to also control their insulin.
Yeah, so what they want to look for, because actually quite often a lot of people will have insulin inside of the reference ranges, and this is a big problem with the reference range. It's quite literally too broad.
It's
And yeah, and unless you're pairing your insulin value with a bunch of other markers to really understand, is it a pathologically high level for you as an individual to capture that? And obviously there's one which is the insulin to glucose relationship, which is the HOMA IR, which I would argue is somewhat better than HbA1c. The thing with the HbA1c is essentially, if you had cancer, then you've got cancer cells guzzling up the glucose. So you're going to have a lower glucose number just from this, and that will lower your insulin as well. But you'll be hypersensitive to insulin growth factor signaling. So your ranges are different. And so that has to be understood. The same with insulin, with other things. What you really want to look at is many days in a row. The most ideal would be at least 7 days in a row of ketones between 4 and 6 p.m. Because if you wake up in the morning, most people, even people who are unwell, will wake up with ketones in the morning because they would have been fasted from an overnight sleep and a little bit of a gap between eating and going to sleep. So you're talking 8 hours to 10, 12 hours even. And so the morning fasting ketones are actually a false positive. So you want to test.
Yeah, this is actually one of the questions I was going to ask you, Isabella. You've stolen my thunder. So the checking your ketones first thing in the morning is going to give you a false positive, like, oh, look how deep in ketosis I am because you just fasted for 8 hours. So what time of day should the average person check their ketones, if they're going to check them at all?
Yeah, so your most ideal is going to be before dinner time. And it could be before you go to sleep even, because it captures your awake day cycle, which is capturing all your activities. But, before dinner time, you've essentially, ideally, if let's say it's between 4 and 6, if you had lunch at 12 or 1, then you're talking about a 3-hour gap, from having eaten something, and then a half an hour to 1 hour before having dinner. And it's basically a tougher test. It's really a much tougher test to see if your lifestyle really is supportive of ketogenesis. And essentially that will translate into whatever it is you're doing is keeping your insulin low enough to not be pathological for you.
I love that. Now, if you're watching this on YouTube, you need to know this important fact. We have a Proper Human Diet tribe, a community, and they get to watch these interviews live, and they also get to ask questions. So I'm always having brilliant experts like Isabella Cooper on the show, and only our tribe members get to ask questions. So B. Rose, if you don't mind, Cooper, 64-year-old female, my new healthcare provider has scheduled me for a BMD, bone mineral density scan, at the end of the month. I'm ketovore, which means typically under 10 total grams of carbs a day and all meat and eggs. Since 2019, do I need the scan? I'll take my part and you take your part. Is that okay?
Yeah, go for it.
Okay, so yeah, B. Rose, I would get the scan. I think any information is always better than no information. I would go ahead and do the scan, but realize it's not a bone strength test. It's a bone density test. You can have very, very dense bones and them still not be strong, just like we were just talking about. But if you have osteopenia, which is basically pre-osteoporosis, also osteopenia, that term is made up by the drug companies that make just to sell more Fosamax and Actonil and the others. But if it is basically pre-osteoporosis. And so if you have that or osteoporosis, then you are at increased risk of fracture, there's no doubt. But you also have to make sure you keep your fasting insulin as low as you healthily can. Anything to add to that, Isabella Cooper?
Yeah, because nowadays there's a bit of a weird one, which is data is population data, especially to the region of where they're collecting their data from the pool. So if you imagine you live in an area with a lot of obese women, they're going to have higher bone mineral density. That's going to shift the average upwards, so to the right of the graph. And then you could potentially fall in a lower bone mineral density, but not really actually have a problem.
Absolutely
So
true. And so many of the tests that doctors order and perform are the results, the normal range is based on population data. And I don't expect patients to understand that. They don't know. They just went to the doctor and did what the doctor told them to do. But I do expect doctors to understand this. But as you know, the vast majority of them have no idea that what you just said is true. They have no idea that if this is an area where there's lots of obese women, lots of women already taking the osteoporosis medications, they're going to have a higher bone density, and that can make a normal woman appear to have osteopenia or osteoporosis when she actually doesn't. And I tell women all the time, when's the last time you fell down? And how forceful was the fall? And so if a woman says, well, I fell off the front porch and I landed on my hands and I didn't break anything, or I twisted my ankle horribly, but I didn't break a bone, I mean, that's prima facie evidence you don't have osteoporosis, right? Almost by definition, although it doesn't meet the BMD criteria, you've got pretty strong bones if you fell off the porch and you didn't break a wrist or something. I think that's pretty good evidence.
Yeah, that is. It's very good. And, going back to the bones, why we do need to keep it really, really healthy is obviously because the bones are the site of where we make our blood cells, red blood cells, and all the immune cells as well. But the hard part of the bones, most people just think of it as scaffolding and that's it. And anyone who's studying any kind of biological sciences, medicine, and things like that, we kind of maybe overly ignore the bones because we consider it sort of quite a boring subject, which is a big mistake. What's being discovered is, we think about muscle cells and muscle being so important. Well, the bones are as important. They are an endocrine organ themselves. The cells that make the bones and the cells that live in the bones, that's the osteoblasts and osteocytes, they're producing so much in terms of hormones that are working on the bone structure, which is obviously going to help with making your blood cells, but also they release all of this out into the system, very closely signaling with muscle cells, but regulating your pancreas, regulating glucagon, regulating insulin, affecting insulin sensitivity, regulating mitochondrial biogenesis. They're doing so much. It's quite insane, actually. So bone health is massively important.
Oh, I totally agree. And most people think of bones like rocks, like they are what they are, and you can't really change them. Half of the bone is made of protein. And, everybody wants to talk about calcium. No, you need to be getting adequate protein in the form of healthy animal protein. That's going to make your bones stronger. And then doing weight resistance and impact exercise. Those are the two things that are going to fix your bones. And don't smoke. Let's talk about continuous glucose monitors. I'm a huge fan. I think every human on the planet at some point should wear a continuous glucose monitor for 2 to 4 weeks, just to kind of see how they react individually to the foods that they eat. And I think it's a great teaching tool. I don't think you need to wear one forever, but I don't think that you're going to cause eating disorders if somebody wears a CGM for 2 to 4 weeks. I think that's foolishness. You've got some thoughts on continuous glucose monitors. Would you share?
So I do think there's value, absolutely, because a lot of people, it's just such a great educational tool in terms of understanding what are the foods that are going to spike your blood glucose, because a lot of people sort of have some misunderstandings about foods. I think the most common one I hear from people, but it's natural sugar, It's like, your body doesn't care.
No, your body doesn't care and it doesn't know. This is one of the biggest fights I've had on Twitter, is saying, the sugar in a banana, that's exactly like the sugar in a Coca-Cola. I'm sorry, but it is.
Yeah, exactly. The part, though, that I say that can be very misleading with wearing a CGM for a lot of people, it doesn't dispute the utility of using one, though. But just to understand this is that you can return back to a normal glucose level very quickly if you produce a lot of insulin. That's not necessarily a good thing. Now, once in a while here and there, fine, no big deal. That's biologically necessary. If we had a hugely stressful event, blood sugars are going to go really, really high. Those blood sugars need to come down, and so to have an insulin response to that would be perfectly logical. And even in terms of human evolution, we would have come across some things that would have been starchy, farinaceous, would have been rich in sugars, and evolutionary humans were opportunists, so they would eat it if it was available. So that happening once in occasions, not such a big deal. But if you do this 3 times a day and likely more, then those huge spikes and frequency of insulin is now going to have a pathological effect. Although your CGM, you're just going to say, well, look, I went back to normal, and that's what physicians want.
Indeed, I see many, it's usually vegan cardiologists on Twitter who will say, yeah, it's normal to have blood sugar excursions, but if it returns to normal really quickly, then that's not a sign of pathology. And I would opine that if you don't know what your fasting insulin level is, if you're severely hyperinsulinemic, then I would expect your blood sugar to return to normal very quickly, but that's not necessarily a healthy marker. So what would you consider? I think for LabCorp, the normal range for fasting insulin is somewhere between 3 and 25. What do you consider a normal, optimal fasting insulin level?
Normal in someone in ketosis or normal in someone not in ketosis? There's a difference there.
Let's say globally, somebody who's trying to realize their optimal health. I don't consider a fasting insulin of 24. You're eating too many carbohydrates if your fasting insulin is 24. My recommendation is to definitely have it under 10, as close to 5 as you can get it. Do you agree with that, or would you add something to that?
Single digits. Definitely single digits. Yes. And definitely mine is really between 2.5 up to 5, really. That's really a much better approximation of where it should be.
I think you're approaching perfection if your fasting insulin is between 2 and 5. I just had my labs checked. I think mine was 6.5 or 7, which I'm fine with that. As long as it's well under 10, I'm happy with it, and in single digits. Let's talk about chronic ketosis. There's been some scary things said about, if you're in ketosis too continuously or too long, you might develop insulin suppression, or it might make you metabolically inflexible. You've been studying these questions for years. Help us understand, are any of these things true? Is this anything we need to worry about? Is long-term ketosis safe?
Well, there's been no human all-of-life studies as trials, obviously. There have been plenty in animal studies. And with animal studies, long-term ketosis in a species-appropriate diet has been shown to extend their lifespan with excellent health span, so reduced, diseases as well, because you want quality of life in a long life as well. And when you look at their markers across multiple species, they correspond. And that's what we look at in humans. We have to use these proxy markers, things that we know are highly associated, correlated, and sometimes we know that they are causal as well. And so with the population group that I've studied, which are women who have sustained ketosis for a group average of 4 years, the longest was 15 plus years, these are women who, when we say sustaining ketosis, it's really part of their natural lifestyle. They've had no previous disease, metabolic diseases, and they're, not taking birth control hormones. They have a hormonal actively reproductive cycle, and they've shown all the markers that we know are either known to be quite causal or strongly associated with the metabolic diseases that we know are the ones that are really getting us all: cardiovascular disease, type 2 diabetes, cancer, dementia, things like that. Their markers look fantastic. Like they look really good. And then what we did was we had them suppress ketosis for 21 days. And, if the argument is that ketosis is dangerous and therefore we suppress it following the recommended dietary guidelines, we followed the UK dietary guidelines where we're based, then the argument should be that those markers should at the very least remain the same if they're looking really, really good. And our hypothesis was, if you accept that being in ketosis is healthy, then our hypothesis was that those markers would trend in the direction of these disease pathologies, not necessarily go right into those numbers, of course. And so we had them suppress ketosis for 21 days and looked at those markers, and lo and behold, those markers significantly changed, trended towards pathology development. They didn't develop any pathologies. They were all within healthy ranges, bear in mind.
Right.
Then we had return back to their lifestyles, which was back into nutritional. And in actual fact, theirs were really more therapeutic levels of ketones in their lifestyle. And purpose of returning back to their lifestyle for 21 days and measuring it all over again was to ascertain, was it the intervention of suppressing ketosis that made those changes? And they reverted majority of those markers, especially the strongest markers, they actually reverted back. There's definitely an order, or in some markers possibly taking longer to return back, but they returned back to their baselines, which was fantastic because it also shows metabolic flexibility.
Absolutely. And that's going to be the next question I'm going to ask you, but I want to make this very clear because this is something that I hear repeated, a myth, a lie, repeated very often out there on social media. So what you just said is that based on all of the available research, the very best research we have on long periods of ketosis, did I just hear you say that there's no recorded negative to that? There is no meaningful research that shows that it's in any way harmful, dangerous, suppresses insulin, causes any medical or physiological problems to be in long-term ketosis. Is that what you just said?
Well, I think there's a big problem in the research with regards to ketosis trials. So it's something that if you see something, well, you should always, have a critical eye on any study in actual fact. But I will say that there is certainly ketosis studies and in humans where the foods are provided, often likely in the style of shakes, as an example, meal replacements. But even if it's whole food, it's, under the misguided understanding and therefore use of things like canola oil, rapeseed oil, sunflower oil, these sort of things that are not necessarily good for health. And so they could show actually negative health outcomes, diets that are super rich in things like fiber that are going to alter stomach pH, that's going to then alter the cascade in the digestive system, which will alter, changes in uptake of, essential nutrients, vitamins, things like that. And so it's not possible to say there are no studies that don't show negative outcome, because you've got to get into the weeds of those studies and whether they were using essentially a species appropriate diet, so the appropriate diet for humans. That really, really matters. In our trial, our female participants were incredibly knowledgeable of human what's sort of most likely ideal and evolutionary appropriate diet. And so they were not eating seed oils, as an example. They were very, very aware of this. So this was included in the intervention phase of suppressing ketosis. Participants didn't switch over to seed oils either. And so those changes, by not switching over to seed oils, essentially, they were able to show the real effect of the carbohydrates in actual fact, rather than conflating and confusing these two. Although I think it would be beneficial probably to do a diet, although highly unethical if you ask me as well, to do a diet where you stay in ketosis and you just switch out the oils for seed oils and then have a look what happens over a duration of time. But I would suspect that most people who are living their lives in ketosis, I would say they probably would actually say no to doing.
They would know better. And so to be clear, you don't consider canola oil, soybean oil, corn oil, peanut oil, you don't consider those to be part of a proper human diet?
Not at all. Not at all. They do what they say on their packaging, which is lower your cholesterol levels. And I would argue that's a good thing. And you have to understand how they lower your cholesterol.
Let's go into that, because I was just reading your opinion on this. So how does switching from lard or beef tallow over to canola oil, how does that lower your cholesterol, and why is that not necessarily a good thing?
Yeah, so it binds to the cholesterol that's coming out in your bile salts. And you have to understand, we make bile for a reason. All right, we make it because it's used for the absorption of vitamin A, D, E, and K, fat soluble vitamins. It's also used for the absorption of omega-3 and omega-6. So if you think that, you know, you're loading your meal with these oils that are going to take that bile out, it's essentially also taking out the transporters for taking in those essential vitamins and fatty acids. So you're going to be net negative. That's a disaster.
I totally agree. Now let's turn and let's talk about something that I've been studying for years, not formally, but armchair studying, and that's melatonin. And I've heard you talk about melatonin, and I think melatonin is a drastically underappreciated thing. Most people think that all melatonin is made in the pituitary gland. They think that it just is associated with sleep. It doesn't really do anything else. You just at bedtime, your pituitary, not your pituitary, but your pineal gland makes melatonin, and then you go to sleep. And that's the whole story. Educate us about the truth about melatonin.
Yeah, so melatonin, you know, if you think about it as a sleep aid, it's kind of like being prescribed an antihistamine to go to sleep. Right. And a lot of people actually do sometimes do that. They'll take an antihistamine to go to sleep. And it's no doubt, you know, it's not in question. Plenty of people, about 90% of people who take melatonin will feel sleepy thereafter taking it. But in actual fact, if you take melatonin in broad daylight in the daytime, you often won't actually notice any real sleepy effect. Melatonin is super rich inside of egg yolks. When we eat eggs, do we suddenly feel sleepy? I mean, we might after, you know, having to digest a meal, but that's rich in melatonin as well. Melatonin is first and foremost an antioxidant. It is one of the oldest molecules in the evolution of cells and then multicellular organisms. And it's a really rich antioxidant. There's a special transporter that melatonin goes into mitochondria. So that's where it specifically is really active and geolocating to. Only 5% is made in the pineal gland. The rest is made outside of your body. And a large amount is actually made by your immune cells.
Absolutely. Yeah. And so the mitochondria, and I find this fascinating because in my studies about melatonin, I've happened upon this fact several times, but all of the mitochondria experts you hear out there on social media, they don't ever mention melatonin with regards to the mitochondria. And so the majority of melatonin is made by immune cells. Yeah, and then utilized by the mitochondria in all of your cells that have mitochondria, and that's where the majority of its action takes place.
Yeah, it's a you know, we always hear about glutathione. You know, it's like a really big sort of word in the antioxidant field. Melatonin is a way more powerful antioxidant. So it geolocates into the mitochondria, and it specifically protects a fatty acid that is mostly in mitochondria. You get a little bit in lysosomes and peroxisomes, but it's basically really and the amount you get in lysosomes and peroxisomes is because they're breaking down damaged mitochondria. And this fatty acid, cardiolipin, melatonin specifically protects it. And it's really important that it does protect it. Cardiolipin is a really sort of weird shaped fatty acid that sort of, you know, if you imagine sort of some sort of upside down kind of spider and the way it moves, it's essential for holding together the enzymes that are part of the electron transport system of the mitochondria. And so you imagine that just sort of being an escalator of how energy, you know, it's really no different to how dams work and how I can't remember the water turbine ones work in terms of energy flow. And these electron transport proteins, the way that they work, their catalytic ability, I know we're sort of getting too much technical, but that cardiolipin is what makes them work. The more damaged cardiolipin is, the less cardiolipin there is, the less those proteins work. That's a big problem. If your mitochondria don't work as well, then the energy production for your cell is going to shift outside of the mitochondria. That's a cancer phenotype, right? And then you have to think about what else do mitochondria do, because everyone just only ever talks about mitochondria and energy. First, it makes your melatonin. Second, it makes your heme for hemoglobin. So that's really important for oxygen transport around your body. Nobody really sort of questions that vitamin D is essential. Well, it's activated in your mitochondria. If you damage your mitochondria and you damage this electron transport protein process, then you're not going to activate vitamin D. All of these things, cells that are really unhealthy, they need to die. And they go through a process called apoptosis. Mitochondria control that. But if you've got damaged oxidative phosphorylation, those electron transport proteins, then the mitochondria can't do it. That's a problem, because now you're going to keep around damaged, dysfunctional cells. If they're cells that naturally divide a lot, that's again part of the cancer phenotype. If they're cells that don't divide a lot, so your heart, but they're really damaged and not functioning correctly, you're going to have cardiomyopathy. And so keeping mitochondria healthy so that they actually can do this apoptosis, it's like, buildings that have asbestos and, they're decrepit, you've got to bring them down, and you've got to bring them down in a really controlled way. Mitochondria do that, but they can only do that if this cardiolipin is present and protected. And melatonin does that. It really hyperprotects them.
I love that. Now, here's a very relevant question from one of our tribe members. And for those of you watching this on YouTube, if you'd like to be able to ask questions with the experts that I interview, become a tribe member. There's a link in the show notes. So Ruth says, besides butter, lard, tallow, are there any other oils such as olive oil, avocado, coconut? Do you consider those part of a proper human diet, or are they problematic as well?
I think that, it's arguable whether you can have those in small amounts in your diet. I've certainly seen plenty of people do fine. They've managed, because you can argue as well that a really healthy body can tolerate a lot of things, right? We know oxygen is oxidative. We tolerate it still. We must.
Right.
But would I say if we had to control the diets of everyone and only give one diet, then the one that's going to maximally be safe and healthy for everyone would have the minimal amount of seed oils. Now, when you think about olives, historically, when we process them to be able to eat them, you get a bit of oil every time you eat an olive, a natural olive. But how many olives are needed to express out enough olive oil that you could eat actually a ton of in a salad? It's quite different, right? So if you make olive oil based mayo, you're going to eat a lot more olive oil there in that one sitting than you could possibly eat naturally just by eating a bunch of olives.
Yeah. So it sounds like you kind of agree with my stance about olive oil, avocado. I think they're probably less bad than canola and corn oil and peanut and soybean oil, but I don't consider them in any way a overtly healthy oil. I think it's probably fine to have them in moderation. It's probably not a big deal. But so you don't really consider olive oil to be a health food?
No, I don't. And in actual fact, it does lower your cholesterol. So remember that. Still taking out that.
Yeah, that's right. That's right. And then another very relevant question from Ruth. We were just talking about mitochondria and the heart. My cardiologist has told me I should not take supplemental melatonin. I have AFib and reverse bundle branch block. What's your take on that?
I would go completely the opposite. I would recommend high dose melatonin.
Absolutely. Yes,
yeah,
I would
really
too. And I love that you brought out the fact that egg yolks are a rich source of melatonin. I've actually never heard anybody to say that before. I wrote that down. I'm looking that up later. I'm going to fact check you and make sure that's correct. I'm sure it is. But yeah, I would absolutely, Ruth, unless, here's the only caveat as a clinician, if there's a direct interaction between melatonin and some medication that you're taking, then maybe this is a good recommendation. But outside of that, this is an ignorant recommendation from your cardiologist. Your cardiac myocytes, you want them to have as strong and vigorous mitochondria as possible. You also want those mitochondria to be able to kill that cardiac myocyte if it's old and damaged and replace it with a new one, which Isabella Cooper just said that the mitochondria are not capable of doing if they don't have enough cardiolipin, and that comes from the help of melatonin. The cardiac function can actually improve when you're in ketosis. It actually gets better on an animal fat diet than it does on a plant-based diet. Also, I would absolutely tell you to supplement melatonin and get plenty of melatonin from egg yolks and other natural sources, unless there's a direct interaction with one of your cardiac medications. What would you add to that, Isabella?
Yeah. Melatonin has actually been shown to help re-regulate blood pressure. So in people with high blood pressure, it will bring blood pressure down. But don't be worried. It's not one of these things where if I take melatonin, I've got normal blood pressure, I'm going to suffer low blood pressure. It's not like that. It's very much about bringing back homeostasis, which is the body's ability to re-regulate these systems. So melatonin is absolutely fantastic for that. And interestingly, the heart is one of the hungriest organs for melatonin. So it gets first dibs, really. What has also been shown is, when someone unfortunately suffers heart failure, and they have a cardiac arrest, one of the biggest dangers is what's called reperfusion. So getting the heart going again, and then a sudden exposure of oxygen, the oxidative damage can really kill off a lot of heart cells. And what has been shown is a really high infusion of melatonin before the restarting can protect against this ischemia damage. And so, yeah, it's really, melatonin is so protective against oxidative damage. That's the key thing. It's protective against that. And that confers all the way to cancer, where cells are really suffering oxidative damage. And melatonin is fantastic in terms of therapeutic for that. I mentioned it to you, Ken, in terms of cancer and the importance of melatonin, because in cancers, mitochondria are incredibly unwell. They're dysregulated, and melatonin, of course, as I mentioned, can bring back a cell's ability to commit this apoptosis and also reduce the general inflammation that's going on inside of the mitochondria. But it gets more interesting, because what people understand with cancer is there's an upregulation of cancer cells utilizing glucose, and they utilize glucose for fuel instead of fat and ketones in a way called aerobic glycolysis. So this is doing this energy, making the cells energy outside of the mitochondria. And in healthy cells, about 87.5% of the making of ATP, the energy carrier, is inside of the mitochondria, and about 12.5% outside. And in cancer cells, that can shift, and it will shift to this aerobic glycolysis to between sort of 50 to 70%. That's a huge shift. And that happens naturally when cells are naturally dividing. So it happens, in embryogenesis. It happens in the intestines when cells need to divide regularly. That's normal. It happens in the liver. It's normal. So it's part of a normal physiology as well. But when that is happening constantly and at a faster rate, then this is a cancer phenotype, essentially. That's growth and division. And then you shut off the cell's ability to die, then you've got cancer. Right. So what you really want to do is you want to stop this hyper upregulated aerobic glycolysis. The final product of glycolysis is pyruvate before it's supposed to go into the mitochondria. And that's not happening with cancer cells. It's going back into glycolysis. Right. And what melatonin does is melatonin makes that pyruvate go into the mitochondria. So it stops this process, and it's incredibly safe and effective thing that you can do. And what was really understood by the researchers who realized this was they were looking at, we typically study people during the daytime. We live during the day and we go to sleep as scientists as well. And a bunch of scientists decided that they were going to study people, tumors in vivo inside of humans, during sleep, and discovered that cancer cells were actually respiring normally during sleep. They weren't doing this upregulated aerobic glycolysis during sleep time. And it was like, oh my gosh, they don't behave with this upregulated Warburg effect, this aerobic glycolysis. So then they looked at what was the thing that was really most closely related to this, and discovered it was actually melatonin. Melatonin was higher whilst you were asleep. And so essentially, if you take melatonin during the daytime, so start your day with lots of eggs, take melatonin on top of it, then you essentially inhibit the cancer cells from this upregulation of aerobic glycolysis, and healthy cells are going to be perfectly fine with that.
I love that. I love that. Let's talk about, so in all your years of studying human physiology, have you ever found any physiological pathway or any biochemical cell and molecular biology pathway where red meat might cause cancer in humans, or might cause diabetes in humans, or might cause inflammation in humans? Have you seen any research, or do you understand a metabolic or a molecular pathway was like, oh yeah, that, meat maybe could do that? Just as a researcher of human physiology, have you seen any research that makes you worry about cancer, diabetes, inflammation from eating red meat?
Well, if the red meat is packaged between two buns with a slather of ketchup and drank down with a shake, then guilty by association.
Uh-huh.
But show me the study where the people were only eating red meat for a long duration of time with no prior disease, and then we can make that determination. We then have to look at evolution and what did humans. We are the survivors of humans who went through the Ice Age. We have their genes.
Yes.
And so that's really important to understand. There are lots of studies that go, oh, but mTOR, it's hyperactivated. And then you have to look at those studies again. When they talk about protein, these kind of studies for activating mTOR, they isolate an amino acid out and they give a pure concentrated amount of this amino acid, like arginine or methionine, to a bunch of mice and then gives them cancer. And it's like, well, what human diet has that level of concentration as an isolated amino acid? So it's incredibly misleading.
I agree. Speaking of isolated amino acids, let's talk about taurine. I love your take on taurine, and I'm going to stand corrected in calling it an amino acid because I'm about to be thoroughly corrected by you. So correct me.
Yeah, it's just, it's always referred to as an amino acid. Nutritionists, dietitians, I would even say some biochemists, they call it an amino. It's not an amino acid. An amino acid is called an amino acid because it has an amine group and it has a carboxyl group. And taurine doesn't have a carboxyl group. It has a sulfide group, in actual fact. So that's number one. So it's not an amino acid. Number two, well, where do you find amino acids? They link up together to make polypeptides and then eventually proteins. And that taurine is not found that way. I mean, you find it in protein foods, so you find it in red meat, but it's not actually part of a polypeptide chain and therefore protein. So taurine, we do make taurine. It's often called a conditional amino acid. And the reason for that is because we don't make what we need. We don't make our daily requirement. It's made in the liver mostly. And it's a really interesting thing that to get it in the rest of your body, you have to secrete it from your liver into your small intestines and then reabsorb it. So it's not going from your liver to the rest of your body. It comes out with the bile and then goes back into the system. So again, let's come back to fiber and seed oils reduce your cholesterol. They're taking out your bile. So whatever taurine you're making, it's been taken out by these seed oils and fiber. Those, just there. But then you also have to think about the trigger to make bile, which includes to make taurine and then secrete that out. That trigger is actually cholecystokinin, CKK, which is coming from the duodenum. And then you have to understand, well, what's the biggest trigger for cholecystokinin? Stomach acidity is the strongest trigger. The second strongest trigger is fat in the diet. Protein has a little bit of a trigger. Carbs and fiber, things like that, have no trigger for it. And if you have a high amount of carbohydrate, even in the form of fiber, remember that's going to increase stomach acidity and bring it to somewhere between 3.5 to 5.5, which is actually not enough to trigger cholecystokinin. Cholecystokinin is triggered when the stomach pH is below 2, a strong stomach acidity. So that's affecting the making of your bile and the taurine, which is so important to trigger that to come out, to collect all the goods from the meal you've just eaten, and then your ability to absorb it, assuming you don't have anything that's going to take out in your stools. And then that taurine is super important for so many things. It's like you don't even know where to start. Bile, just as a side note, has an effect on adipose tissue, helping turn it from a white adipose tissue to a brown adipose tissue, brown fat, which essentially means more mitochondria. That comes from taurine as well. Why the taurine? So taurine, it geolocates again to the mitochondria. And it's really, really important because you have some RNA inside of your mitochondria that is reading the DNA from the mitochondria, who have their own DNA. And they've got to make those electron transport proteins for oxidative phosphorylation. And taurine is essential in that. If I don't want to get too technical, but it affects what's called a wobble protein. And essentially, when that messenger RNA is being read to find the correct amino acids to place together to make this protein, if taurine is not there, the wrong amino acid is picked up. And then with that protein, that enzyme for the electron transport chain is actually less efficient. And when it becomes less efficient, you get more electrons essentially falling off of the electron transport chain. It's like you're on an escalator and you need people at the bottom of the escalator to quickly move forward and out of the way. And if they don't move forward and out of the way, then there's going to be a log jam and people are going to start backing up. And the people at the top are actually going to start falling down. And it's huge, disaster. And that's the same with electron transport chain. They've got to move really well. And if those electron transport chain proteins are made incorrectly, they're inefficient, those electrons don't, they're going to start falling off. And then those free electrons are going to react with oxygen. They're going to start damaging the cardiolipin, damaging the mitochondria. So that's how important taurine is, just there. But taurine's also an antioxidant. It actually plays another role as well. So super important. So even though you're making not all that you need some from your diet. It's basically from meat and eggs. And so you need the combination of what you make, what you eat, and removing things that prevent you from absorbing it in your intestines.
Should taurine be considered an essential nutrient? And if somebody's on a exclusively vegan diet, should they take a taurine supplement?
Definitely, if you're on a vegan diet, so take a taurine supplement, absolutely. Because, again, even though you can make it from cysteine, a vegan diet is going to inherently have foods that are going to take it out of your digestive system. So you need to find ways to get it into your system much, much more. If you have an unhealthy liver, you're likely not making as much taurine. Things like this. So yeah, you're going to need to supplement with it. Should it be considered an essential? Well, taurine is actually essential for the absorption of the fat soluble vitamins and essential fatty acids. It's an essential part of it. And so, again, if you're eating a proper human diet, essentially, then if you are not unwell, you do not need to supplement with it. But if you have a pathology, you might want to think about that. But that said, I'm a big believer that a really good diet should therefore not require too much supplementation. You have to then be nuanced to understand what your health condition is. If you have hypochlorhydria, not enough stomach acidity, well, this is going to be playing a role in the triggering of making bile, the triggering of the bile to be secreted. Because remember, you need strong stomach acidity to trigger cholecystokinin. So you have to think about these things. And I've not met someone who's hyperinsulinic who doesn't have hypochlorhydria, in actual fact, which is not enough stomach acidity. Yeah.
Excellent. So, do you mind sharing what supplements you take, if any?
I don't take supplements on a regular basis myself. Very thankfully, I am very healthy. I have, by chance, been living a lifestyle of being in ketosis since my teens, I would say, really, probably even earlier. So for me, having had plenty of blood tests, I don't appear to be deficient in anything. So again, it kind of does demonstrate that having the right kind of diet, produce, the diet that helps you produce stomach acidity and things like that should make you nutritionally replete. Now, that said, if my children are unwell from catching something at school or we're traveling and I think that it might be beneficial, I then would probably take some vitamin D that's in a coconut oil. In this case, it isn't a coconut oil, or maybe a sublingual form that's very absorbable. I do look at things and make sure that there are no seed oils inside, that there's no sort of dextrins, maltodextrins, rice flours, things like that. If you're taking vitamin D, I would always include vitamin K2, and I would look for K2 that has MK7 or MK9, either or both, because MK4 is not actually enough. We can't make MK7 or MK9. And so those really should go together. Magnesium, if you wanted to, it's beneficial, it's net positive. Myself, I will say that I don't. Truth be told, the first thing, if I think that I'm really deficient on something, which is really uncommon and rare, the first thing I go for is very nutrient dense foods. It's going to be eggs, the whole egg. It's going to be small oily fish and liver, those sort of things, or organ meats. But you don't have to eat those things. If you don't like organ meats, eat some small oily fish. But like I said, eggs are actually so fantastic that if you're eating plenty of those on a regular basis, you probably don't even need to worry there. And melatonin, if I had to pick one thing, it probably would be melatonin. Is the one that I would say, take it. We can go in the sun for vitamin D. We can eat. Actually, that's something really important for some people to know. When you supplement with vitamin D, and I do think it's beneficial, it's cholecalciferol. Well, ideally, you should be supplementing with that form.
Yeah,
when you make vitamin D, it's not the same. It's cholecalciferol sulfate. It's a sulfated form, so it is different. The only food form that has that is egg yolks. So again, egg yolks, amazing. Less cooked, the better, meaning just don't overcook them so they're rock hard or dry and rubbery, essentially. But make sure your egg whites are very, very cooked, not like crazy very cooked, but very cooked, because albumin actually will alter the stomach pH and induce more hypochlorhydria.
Sunny side up. Yeah. Runny yolk, firm white. That's exactly my recommendation as well. Do you think it's, I got two more questions if you have a minute. Do you think it's possible to achieve optimal personal health eating a vegan diet?
Oof. Do I think it's possible? Well, I think that.
Well, let's say with supplementation and without supplementation, because what I talk about is a proper human diet, and I base that on the diet that we know humans ate more than 15,000 years ago, right? And so if you went back in time, there was no supplement store, there was no protein shakes, there was no, and you said, okay, go back in time 15,000 years, I want you to eat a vegan diet. Would you live? Would you be able to reproduce? Would there be ancestors of you? I mean, would there be a progeny of you today currently, or would your line have died out?
Yeah, I think our line would have died out. So, I mean, first of all, young children absolutely should not be put on a vegan diet. This is shown to be very dangerous for them, actually.
100%.
So the fact that young developing children can't be on a vegan diet should tell you a lot, because the best diet is the diet that all stages of life will thrive on. That's number one. Number two, if you go on a vegan diet during teenage years, it seems to interfere for girls with having their menstrual cycle. That's of concern as well. The ability to have a healthy menstrual cycle at the right age of life is, indicative of healthy physiology as well. And so again, it's a big red flag. Then, if you've gone through, let's say, childhood and puberty on a proper human diet, on one that you're thriving on, and then you decide to go and become a vegan, that's certainly less dangerous than it starting at a much earlier phase. That's for sure. The questions then would be exactly as you said, supplementation and all of these sort of things. How do you manage it? And I don't think we have any really strong, good evidence in terms of really, long term what that's going to look like. There's no population in the world that is, a largely overall vegan diet. We have to use a lot of association data, unfortunately. So we can't really say people, and the biggest problem with the vegan sort of plant-based diet, I wouldn't say the biggest problem, but most people who've decided to go vegan or to remove as much animal food as possible, it's because they've got a health problem, or they've just become aware that nutrition is a good thing to modulate for a better lifestyle. Once you start to become aware of that, you usually start eliminating bad foods out of your diet. That's just, the norm, whether you go more animal-based or plant-based. So you're going to have immediate health rewards from that. And so you'll see that even in plant-based and vegan diets. And so that's something to bear in mind, that there's usually quite a window of a health benefit. Then there's other aspects. So you've got to look at studies where they say plant-based diets, because a lot of plant-based diet studies are not 100% vegan diets. There's a intermittent frequency of having a bit of eggs and a bit of fish, things like that. So it's very, very misleading. Studies should be able to stipulate very clearly that it was 100% vegan diet, or if it wasn't 100%, what were the little things that were included that managed to sort of help you get away with it, let's say.
Absolutely. Here's a question. A lot of people are freaking out about eating liver. They're like, no, vitamin A toxicity, copper toxicity. You've been studying human nutrition and human digestion for a few years now. You've been in nutritional ketosis the majority of your adult life. I think you probably eat liver. Have you ever seen, I've never seen a documented case of somebody eating the liver of domesticated animals and develop a vitamin A toxicity. I can't even find a case report of this. Yeah. Is there any danger if somebody loves liver and they want to eat liver 2 or 3 times a week? Is there any danger of vitamin A toxicity or any other toxicity developing?
I've not seen any studies myself that have shown it either. I would say I've seen more evidence of supplementing with vitamin A toxicity.
Yes. 100%. Yes. If you take a vitamin A supplement, you can develop toxicity. Absolutely. Yeah. But from eating retinol vitamin A as it occurs in natural form in the liver of domesticated animals, do you have any fear that someone might eat too much liver and cause a problem?
You'll actually feel a little bit nauseous when you eat too much. The body's quite sensitive to that, funny enough. I would say with regards to vitamin A, eating too much fat along with too much salt. So I'm a big proponent of taking in salt, but your body's very good at telling you if you've had too much. And so you will find if you've eaten too much rich in vitamin A that you'll actually start to suddenly feel a bit nauseous. And by the way, vitamin A is rich in egg yolks again. And so, people who are getting all worried about eating liver, and if they eat tons of egg yolks, it's like, well, you're getting plenty there. So first of all, you don't need to seek it therefore elsewhere. So I wouldn't supplement in that instance. And then secondly, do you feel nauseous when you're eating eggs? And you often find that you don't, and you can eat loads and loads and loads. So I'm not really worried about it in that respect.
I love that. Isabella Cooper, PhD research scientist, thank you so much for hanging out with us this afternoon inside of our private community. I can't wait to meet you in London at the upcoming Metabolic Summit event. I'm following you on Twitter. Where else can people follow your work and glean your knowledge?
So I'm on Twitter and I'm on Facebook. Twitter is really where I'm really more active than anywhere else, but Facebook too. There is a website, but I don't really sort of post much. It's just a way to contact me more than anything else. And that's foreveryounggroup.com.
Excellent. Thank you so much. I'll see you in London soon.
See you soon. Bye.
All right.